So yesterday we talked about radicals and being able to graph radicals, both cubic roots and square roots. Now the next 2 days we're going to spend on section 5.4, which is solving radical equations. Today when we solve those radical equations, we're going to make sure that everything we have is kind of linear. So we're going to get an x equals something or an r equals something. Tomorrow when we solve these, we're going to end up with having to do some quadratic stuff, x squared plus 3x plus 4, whatever, where we're going to be asked to do some factoring and that type of thing. Today, however, all of our answers are going to be linear. So it'll just be pretty straightforward with answer-wise. You're not going to have to factor and do anything like that. So the two examples I have up there now are talking about how do we find the value of x. So the first one is asking the square root of what number is equal to 8 is really what that first one is asking. And you can kind of think about it in your head. The square root of what is 8? Well, the square root of 64 is 8. So we know this answer for this first one has to be 64. Because remember, when you take the square root of something, you're taking it times itself. And 8 times 8 is 64. So the square root of 64 is 8. We need to be able to show how to do that algebraically. Well, technically speaking, what we have written here is we really have written here x to the 1/2. And it's kind of the same thing. These two things mean exactly the same thing. And not that you would necessarily do it like this. You probably wouldn't do it like this. But as for an explanation of why this works really well with what we've been doing with the exponents. So remember, when we rewrite a rational as the exponential form, our index goes in the denominator, the power is in the numerator. Now, we want to get x by itself. So when we've talked about working with exponents, we said that when you take exponents, you multiply exponents together. So if I take this and square it, and remember mathematically what you do to one side of an equation, you also have to do to the other side of the equation. And once you've done that, you've really changed nothing. Okay? As long as you've kept that kind of balanced. Now when we go power to power, you multiply. So if I take 1/2 times 2, which is 2 over 1, that gives me 2 over 2, which is just equal to 1. So all I have left here really is x. And then in this case, 8 squared is 64, is exactly what we said it should be. Okay. So we kind of do this. We can kind of do this power to power thing. Now, are you going to use power to power to do these? Probably not. Okay. How do you get rid of a square root? You get rid of a square root by squaring something. Okay. Do you have to write it as 1/2 x to the 1/2 power? Certainly not. I just wanted to show you that mathematically why it works when we do what we do. So if we look at this second example, we're going to kind of use the shortcut to do this second example. So we've got the square root of x plus 4 is equal to 7. Instead of writing this, and don't write this, instead of writing this as x plus 4 to the 1/2 power equals 7, all we're going to do is simply say, how do you get rid of a square root? You get rid of a square root by squaring it. And we just kind of proved that on this side over here. Essentially, this is a proof of why what we're about to do works. So all we're going to do instead is we're just going to square this side and we're going to square that side. Don't worry about rewriting it. When you square a square root, those two things cancel each other out. We're just left with what's underneath the radical symbol. And then make sure you square 7 as well. 7 squared is 49. And now you're simply solving for x. It's linear. Subtract 4 from both sides and get x is equal to 45. And just like all equations, you can always check to make sure that it works. 45 plus 4 is 49. Square root of 49 is 7. It checks out and it works. And you're done. So how do you get rid of a square root? You square both sides. How do you get rid of a cube root? You cube both sides. How do you get rid of a fifth root? You take it to the fifth power, and so on and so forth. The next two questions now, at least the next question, -1 is equal to -7 plus the square root of b plus 8. Let's make this a little bit bigger so everybody can kind of see it. One of the things that you have to make sure you do if you have square roots is you need to make sure that you isolate the square root first. So we want to get the square root on one side of the equation and everything else on the other side of the equation. So in this case, I've got -7 being added to my square root. So I'm going to go ahead and add 7 to each side of this equation. By adding 7 then, I end up with 6 is equal to the square root of b plus 8. And we want to do that first because if you try to square this whole thing first, it becomes a mess. Could you do it? Yes. It would be a lot more difficult than it is right now. So isolate that square root first. Now we just fall back to what we just were doing. We're going to go ahead and square both sides. And make sure you square both sides. 6 squared is 36. The square root of b plus 8 squared is just b plus 8. Now solve equations like you've been doing for the last 4 years. Subtract 8 from both sides. You get b is equal to 28. And again, you can check it. 28 plus 8 is 36. Square root of 36 is 6. -7 plus 6 is -1. It works. You're done. Okay. Whole key to this is making sure that you isolate. If there's only one square root, make sure you isolate. There might be cases where it's a little bit different if there's two, but if there's only one square root or cube root, radical, make sure you do that. Okay, so now let's look at the next one. So the next one, we're working with cubed roots. So we've got the cubed root of r minus 9 is equal to 3. It's isolated already. There's nothing being added or subtracting to our radical, so we're in good shape there. Now we're dealing with cubed roots. So to get rid of a cube root, you cube. Left-hand side, you're left with r minus 9. 3 cubed. 3 times 3 times 3. 3 times 3 times 3 is 27. Add 9 to both sides. R is equal to 36. Right? Yes. 36 minus 9 is 27. Cubed root of 27 is 3. It works. Any questions so far? So far all make sense? Not so bad yet. Okay, now let's look at it like this. So instead of now having it written as the square root, now it's going to be written to the 1/2 power. So the first one, give you a second to write that down. We've got r plus 6 to the 1/2 plus 5 is equal to 6. If you need to rewrite this, if I have something to the 1/2 power, remember this is just the same thing as the square root of r plus 6 plus 5 equals 6. Those two things mean the same exact thing. And when I did that first problem today, it said the square root of x was the same thing as x to the 1/2. That's just taking it in that opposite directions, and that was part of your quiz that you took last week, being able to rewrite it. Now, if we look at it like this, now it's just like one of the problems that we just got done doing. So we're going to subtract 5 from both sides. That gives me the square root of r plus 6 is equal to 1. Square both sides. So that's r plus 6 equals 1 squared is 1. Subtract 6 from both sides. You get r is equal to negative 5. So again, it's kind of one of those things, if you need to rewrite it, rewrite it. If you can recognize that I can just square it at that point, certainly could do that too. But again, make sure you isolate that first. Always has to be isolated first, and then you can solve away. So go ahead and solve negative 2 minus 33v to the 1/3 equals 4. Go ahead and find the value of v, So since everybody's talking so loud, I'll rewrite it. It's the same thing. If you just cubed it right away, even better. So that's negative 2 minus 33v equals 64. 4 times 4 times 4, 64. Add 2. Negative 33v equals 66. V equals negative 2. Does that look right? Did everybody do okay? So subtract 9. Since I'm here, I'm just probably going to rewrite it. Negative 3 minus m, it's the square root of it, equals 1. Square both sides. Negative 3 minus m equals 1. Add 3. Negative m equals 4. Multiply by negative 1. M is equal to negative 4. Solving equations part's a little bit more difficult to solve that one. Obviously, not showing the steps, and that's what you guys can do too. You don't need to show all the steps. You guys can do these by now. Last one. And then we'll let you get going for the day. So that says 1 is equal to negative 2 plus 9a to the 1/3. And that whole 9a is risen to the 1/3 power. Answer is up on the board. Take a peek at it, see how you did. So that's the first part of 5.4, part A. Solving equations when everything is linear.